For this hyperbola, I'm going to go ahead and show you what Alex's answer looks like because I want you guys to have a nice clean picture, and I'm having a hard time trying one with this magic pen that I have. So this is the equation, and this is the answer. And here's how Alex is getting this hyperbola from this equation. The first thing is we would know ahead of time that it's going to be a hyperbola because we have the x squared, we have something with a y squared, and it's that minus sign that tells us some sort of hyperbola. We know we want one side to equal 1, so in this particular example, it already is equal to 1. If it weren't, I would go ahead and divide through by whatever this value was. And I see also there's some shifting going on. So there's no shift in the x direction, there's no left or rightness going on, but there is definitely a shift in the y direction. And, we'd want to make this 0. So that means y would have to be negative 3. So we see that they put this point that normally would be at 0, 0, and they shifted it down to 0, negative 3. Because of course, if you let x equal 0, then you'd be at the 0, 0. And if you let x equal negative 3, then this part is 0. So that's where we're going to start. Because you would square 5 to get 25, from this point, they've moved 5 points to the right and made a little guiding point, that little x. They've moved 5 points to the left, they've made a guiding point. Then, because you would square a 4 to get this 16 from the center point, since the 16 is with the y, we're going to go up 4 points, we're going to go down 4 points. And that's from what the points that would have been, the ones that were marked and the ones we would have made that were 4 above and below that center value, they went ahead and drew in this rectangle. And after they drew in that rectangle, they connected the diagonals to make the asymptotes. And then finally, because this thing led with an x squared, they knew that their hyperbola opened in the direction of x versus y. So the next thing was to draw a hyperbola that went through this point and went through this point and approached these lines opening in the direction of x. Hopefully not too shabby. Hopefully as we do these, you're kind of understanding the difference between how an equation of an ellipse differs from that of a hyperbola from that of a parabola. Good luck. The next kind of conic section we're going to look at is called a hyperbola. And they're going to have this shape where it's almost like two separate parabolas pointing in separate directions. Some hyperbolas look like this, some look like this. I want to be clear that that both of these pieces make up one hyperbola. Both of these pieces make up one hyperbola. And the way we're going to graph these things is very similar to the way we graph ellipses in many ways, but obviously not quite because this is nothing like a circle at all. So what's going to happen, here's where the similarities are going to be. These types of equations will have an x squared as well as a y squared. And just like before, we are going to want to make sure that those things are equal to 1 instead of some other number. But the big difference here, if you haven't figured it out yet, is that it's minus instead of plus. And so that's how we know it's a hyperbola and taking on a shape like these versus a circle or an ellipse. The other thing I want to mention is when you're trying to determine which of these two shapes you're actually going to have, it all is based off of which of these guys is positive. So if you're leading with the x squared term, it's going to open in the direction of the x-axis. So this is like the ones that are of the form x squared minus something y squared equals, something. And then if it's an up or down one, it's leading with a y squared, then minus the x squared equals something. So this one we know is going to open more like in this direction of these. So step 1 is to go ahead and make sure that one side of this equation equals 1. So I'm going to go ahead and divide everything by 16. So I'm going to get x squared over 16 minus a y squared equals to 1. That's what happens when I divide each of these by 16. And then very much like before, but for reasons that are a little bit more than I want to explain in this video, we're going to go ahead and look at what did we square to get this number. We would have squared a 4. And then what did we square to get the bottom of this? Well, there's no number listed there, so we can go ahead and assume it's a 1, and that means we squared a 1. And much like before, these are kind of have a center at 0. And what I'm going to do is in the direction of x, I'm going to go 4 to the right and 4 to the left. 1, 2, 3, 4. 1, 2, 3, 4. And then since I squared a 1 to get to this guy's denominator, from the center I'll go up 1 and then I'll go down 1. But instead of like connecting these with a big ellipse like we did last time, we're going to draw a dotted rectangle. It's not really part of our graph, but it's going to help us figure out how to draw in these shapes. Because one of the things these shapes do is they start to approach these slanted asymptotes. So that's what a hyperbola does. It'll kind of like will go out like this and go out like this. So I earlier referred to them as kind of like parabola type shapes, but they're not really like parabolas at all. Like there's a lot of properties parabolas have that these don't have. These have kind of this asymptotic behavior where they'll approach this slanted line and this slanted line. And this rectangle I drew is how we find those slanted lines. If I connect from this corner to this corner, a straight line should go through that center, which in this case was 0, 0. And then from this corner here to this corner here, draw another slanted line. Should also hit the center, which in this case was 0, 0. I'm going to get these asymptotes, which you might remember from previous sections. Asymptotes are these lines that the graph approaches but never quite touches. And because this thing led with an x squared, I know that this point here, this one that I drew earlier, that's actually on my graph, and that's actually on my graph. And here's one thing I can definitely make sense of in the time I have in a under 10-minute video. This point, I know that this hyperbola will open in this direction because I know these points have to be on the graph. And these other points I use, this 1 and -1, they are definitely not going to actually be on my graph. And here's how I know that. If I consider the original equation, well, that I reduced down to x squared over 16 minus y squared equals 1. And if I were to consider making y equal to 0 and having this whole part drop out, so forget all this, I can see that positive 4 and -4 make this equation true. If I take 4 and I square it and I divide it by 16, that equals 1. If I take -4 and I square it, that's positive 16. Divided by 16, that's still positive 1. So both these points are on the graph. On the other hand, if I take that x squared over 16 minus y squared equal to 1, and I drop this part of the equation out, these points don't actually make that equation true. If I take 1 as my y value, and I plug it in and I square it, 1 squared is 1, but then I have to make it negative, so it's not going to be a true statement. So while these points on the y-axis are instrumental, because they help me get this rectangle correct, so it helps me get these asymptotes, they're not actually on my graph, because this thing led with the x squared. When the equation leads with the y squared, everything I said is exactly the opposite of it's true. So now that I know this point's on the graph and this point's on the graph, and I drew that rectangle based off the x and y values, and I put in these asymptotes that connected corners, now I'm just going to draw a graph that goes through this point and then it starts to hug these asymptotes. So it gets closer and closer to them, like this and like this. So in a lot of ways, this is just like doing an ellipse because we're starting with those 4 points, but instead of connecting with the circular shape, we're doing the rectangle, we're throwing the asymptotes down, and then we just got to figure out if we're drawing the one that goes this way or the one that goes the other way. Good luck with these.